Open a map on your phone, and a small blue dot appears almost instantly. It can guide you through a new city, find the cafe you saved last week, or show exactly where you stopped your car. But how does a phone, sitting quietly in your hand, know where it is on a planet this large? It is not being watched from space. In fact, the phone does something much simpler. It listens. High above Earth, GPS satellites continuously broadcast radio signals. Each signal includes two vital clues: where that satellite was and the exact time the signal left it. Those timestamps are incredibly precise because GPS satellites carry atomic clocks. Your phone does not need an atomic clock of its own. It only needs to compare several signals arriving from space. Radio signals travel at nearly the speed of light, so if your phone knows when a signal was sent and when it arrived, it can estimate how long the journey took. Then it uses one simple idea: distance equals speed multiplied by time. A tiny fraction of a second becomes a distance from your phone to one satellite. One distance does not reveal one location. If you are, say, 20,000 kilometers from one satellite, you could be anywhere on the surface of a huge invisible sphere around it. One signal gives you a very large set of possible places. A second satellite narrows the possibilities. A third narrows them even more. This method is called Trilateration. It is about distances, not angles. Imagine each satellite creating a transparent sphere around itself. Your phone must be somewhere on every sphere at the same time. Where those distant spheres meet is the answer your map is looking for. On a flat drawing, you may see circles. In the real world, GPS works in 3 dimensions, so the geometry is made of spheres. For a real 3-dimensional position, a GPS device normally uses at least 4 satellite signals. Why not stop at 3? Because your phone's clock is good, but it is not an atomic clock. Even a tiny timing mismatch would turn into a very large distance mistake at the speed of light. The extra signal helps the receiver solve both its position and its clock offset. 4 satellites turn a clever estimate into a usable blue dot. There is an important detail here. GPS satellites do not measure the distance to your phone. They do not receive a reply from it. They simply broadcast. Your phone receives several signals, reads their timing data, and performs the calculation by itself. The location estimate happens inside the device in your hand. Of course, real life is messier than perfect geometry. Signals can be delayed slightly by the atmosphere. They can bounce off buildings before reaching your phone. And when visible satellites are clustered in one part of the sky, the geometry is less helpful. That is why your blue dot can sometimes wander, especially between tall buildings, indoors, or under dense cover. GPS is also more than a map tool. Precise satellite time supports systems that need synchronized clocks, including communications, power networks, and finance. So every time a map finds your location, it is using a worldwide timing system built from radio signals, orbital data, and geometry. Your blue dot is not magic. It is a quiet calculation. Signals travel from space, time becomes distance, and several invisible spheres meet around you. That is how GPS turns a few radio signals into the answer to one of the most useful questions in daily life: where am I?